All right, guys, let's finish up the chapter 2 part of our review. Starting with number 19 now. It says to solve the polynomial inequality. Okay, so when you're solving polynomial inequality, first thing is to get one side to 0. So let's do that. This 3x squared, I'm going to subtract from both sides. Also subtract the 2x from both sides. So I'm going to get x cubed minus 5x squared plus 2x plus 8 is less than 0. Okay, now the next thing I want to do is basically I want to treat this as like as if I was about to graph a polynomial, right? Think about it like I want to know that when this thing is above or below the x-axis, right? So that what's going to help me is figuring out where are those zeros, and then what does the graph look like from there, right? Or how does it deal with those zeros? Once I have those zeros, then I can look, okay, where was it above or where was it below, in this case, the x-axis. So basically, I want to almost get to the point of graphing. I don't have to actually physically graph it, but I want to basically get to the point of graphing. To do that, I want to know where the zeros are. And to know where the zeros are, I'm going to look at what are my possible rational zeros first. Well, last coefficient is 8. This coefficient is 1. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Those are all the natural choices to check. So let's start by checking plus or minus 1. Here's my coefficients. So, even though it says solve the polynomial inequality, you might think, oh, that's a very different question from what we've been doing. But no, it's just pretty much the same approach as if you're going to graph a polynomial or find the zeros first, right? 1 comes down. 1 times 1 is 1, plus negative 5 is negative 4, times 1 is negative 4, plus 2 is negative 2, times 1 is negative 2, that's positive 6. So that's a no-go. Let's try negative 1 instead. 1 comes down, times negative 1 is negative 1, plus 5 is negative 6, times negative 1 is positive 6, plus 2 is 8, times negative 1 is negative 8, plus 8 is 0. So I found one. Sweet. That's x squared minus 6x plus 8. And that is a quadratic, so I'm going to go ahead and use the quadratic formula now. That's negative b, which is 6, plus or minus the square root of b squared, which is 36, minus 4a, which is 1, c, which is 8, all over 2a, which is 2 times 1. And 8 times 4 is 32. So it's going to become 6 plus or minus the square root of 36 minus 32 is 4 over 2, which is plus or minus 2 over 2. And let's split that into two parts. 6 minus 2 is 4, divided by 2 is 2. Or 6 plus 2 is 8, divided by 2 is 4. So negative 1, 2, and 4, those are my zeros. All of multiplicity 1. So I'm ready to basically sketch the graph, actually. I think that's maybe I should go ahead and sketch the graph, yeah? Sometimes you do the sign tables and blah, 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 but to me, it's maybe easier just to go ahead and sketch because I already know the multiplicities. And if I just look at end behavior, that's going to help me figure out what's going to happen. Here, let me plot my zeros first. End behavior tracks with the x cubed, right? X cubed is going to be negative to start. And then it should finish positive. Okay, and then I want to know when this thing is negative, because that was the original question here, right? Where is it negative? It's negative down here and in between over here. So here's the solution. Oh, whoops. Solution in red. This is negative 1 here. This is positive 2. That's positive 4. So here's the solution. You want it to be strictly less than 0, so everything should be open brackets, negative infinity up until you hit negative 1. and then unioned from 2 to 4. So there you go. That was 19 just now. Forgot to label again, but that was question number 19. Okay, as I'm erasing, let's look ahead to number 20. 20 is about graphing that thing eventually, yes. Graphing that rational function. Starting by finding vertical asymptotes, horizontal or oblique asymptotes. Okay, so vertical asymptotes first. Okay, first thing actually is just to write this thing in factored form, and these are nicely factorable things. X squared minus 9 is a difference of squares, x plus 3 and x minus 3. In the bottom, when things that multiply to negative 8 and add to negative 2, that will be negative 4 and positive 2. So x minus 4, x plus 2. Okay, so answering 20, part A, vertical asymptotes are going to be x equal to 4 and x equal to negative 2. Okay, part B, horizontal asymptote or oblique. Oblique happens when the power is one more in the top, and then you got to do the long division, but they're equal in this case. So that means I got a horizontal asymptote at y equal to 1. How do I know it's 1? Because I just divide the coefficients of those two things. So, okay, that's that. And then letter C, complete the statement. As x goes to negative infinity, f of x is going to approach that asymptote. And same for positive infinity. It's going to approach that asymptote. Okay, so now we're going to go ahead and graph. Starting with asymptotes. Let's plot those guys. So positive 4, 2, 3, 4. Yeah, and then negative 2, 1, 2. Okay, so in between, I gotta figure out where I am. Also want to know. I also want to know keep in mind my zeros. Yeah, so my graph is 0 at positive 3 and negative 3 because those are the things that make the top 0. So positive 3 is right here, and negative 3 over here. Those are zeros. I also have a horizontal asymptote at 1. Okay, and then okay, I kind of have a picture already. What's gonna happen? What typically happens with something like this is, okay, this guy is a point there. It's below the asymptote, so it's probably gonna approach like this, which makes this one probably up here because there's no crossing of zeros down here. Now in between, just by where this is positioned, my intuition tells me probably something like this. A lot of people had this wrong in the exam where they had a similar graph, but they drew something like this or like this, when in fact the correct answer had a sort of diagonal thing. The way to check that is to check, like, well, there's a couple ways actually. In the case of the exam, I think we had our horizontal asymptote was right in the center, so it made sense to check where you're positive or negative to see if you cross or not. In this case, we kind of have a special case. I don't know if this is going to cross or not here. I actually don't know if there's some other cross. So what I do want to check is there an instance when this equation is equal to 0? So I'm sorry, not 0, 1. Is there an instance when f of x is equal to 1, that 1 is where the horizontal asymptote is, right? And what is f of x? Well, f of x is this function right here. So I want to check if that thing is ever equal to 1. So let's do a little side calculation to check here. So this is just to check if I actually am going to touch that horizontal asymptote. If so, when? So when is x squared minus 9 equal to x squared minus 2x? Oh, I'm sorry. I'm kind of getting ahead of myself here, guys. Skipped a step. I don't want to lose you here, so let me go back. So this is the function, right? F of x. I want to know if that's ever equal to 1. If there's a solution to that, or solutions, then it will be true. How do I solve this? Multiply both sides by the denominator, which gives me what I had written a moment ago. X squared minus 9 is equal to x squared minus 2x minus 8. Next thing is the x squareds cancel each other out. So I got minus 9 is equal to negative 2x minus 8. But then add 8 to both sides. I got negative 1 is equal to negative 2x. And so x is equal to, divided by negative 2, 1/2. Okay, so what that tells me is that at when x is 1/2, then I'm at 1. So where's 1/2? It's over here somewhere. And I'll be exactly at 1. So this is a point right here. So I cross at that position. I know I have to hit that number there. So that tells me my graph must do this. It's going to approach the asymptote. It's going to hit that value and then go down. If you want to be extra sure, you can do a test point right here. Plug in negative 1 into your function and see what happens. Into this thing. Negative 1 squared is 1, minus 9 is negative 8. And then negative 1 squared is 1, plus 2 minus 8. So that's going to be what, 9? Negative 9. So I got negative 8 up top, negative 9 down below. Actually, let me do it. Let me actually do it instead of talking through it. I'm going to check negative 1. Okay, so up top is negative 1 squared is 1, minus 9 is negative 8. The bottom it's 1 plus 2 minus 8, which is negative 8 over 1 plus 2 is 3, minus 8 is negative 5, which is 8/5. Okay, 8/5 is bigger than 1, so it's above, yeah? So, okay, yeah, where I expect it to be. Okay, so that means left side looking good, right side looking good. And then this part, it doesn't make sense to be down here because then I would have crossed the x-axis again. So that means I must be up top. And again, you can check test points if you want to be extra sure. Anyways, that finishes the sketch. So we've done all this stuff. We've done all that stuff. Now just to state the domain and range. Domain. Okay, domain is everything except for these two vertical asymptotes, right? So I could write it interval notation, but the easier way is to just write where x is not. X is not equal to negative 2 and x is not equal to positive 4. Okay, what about the range? Range, okay, I got everything down below, right? I go as far as low as I want. Everything up top as far up as I want. In fact, if I just look at this center portion, right there, I'm getting everything. So the range is everything. Negative infinity to positive infinity. And that's 20, guys. We did it. All right. 21, variation. Okay, these are easy, but let me get my calculator because I don't want to do computations. Okay, let's start by interpreting first. 21. Y varies directly with x. So y equals to kx. Oh, it's the simplest case, yeah? And then y is 12 when x is 4. So this is going to help me to solve for k. So 12 equals 4k, that means k is equal to 3. So now I have my k. Let me rewrite my variation. Y is equal to 3x. That's my variation. Find y when x is 5. So y is equal to 3 times 5, which is 15. Okay, didn't need my calculator for that one. Just a reminder, guys, scientific calculators only. Don't be using your graphing calculator to graph things. Okay, 22. Okay, we got a word problem here. At constant pressure, the volume V of the gas is directly proportional to its temperature T in kelvins. All right, let's just stop right there and write what we got so far. So volume is directly proportional to temperature. If, is that it? Oh, that's it. Another easy one, okay. The bicycle tube is filled with 1.2 cubic feet of air, that's a volume, so 1.2 cubic feet of air, at temperature of 295 Kelvin, so that's the temperature. What would the okay, blah, blah, blah. Before we move on, let's just pause right there and just solve for a K. So K is going to be 1.2 divided by 295. And then let's get approximation there. (1.2) divided by 295. So K is approximately 0.0040677966. I'm going to keep the long one right now just so that I don't lose accuracy in my final result. When I get to the final result, then I'll round to, it doesn't say, yeah, so we'll go with however many decimal places were in the question, which is 2. Okay, so my new equation then is V is equal to 0.0040677966 T. Now what's the question? Where we finish off? We finish off right here, yeah? What will be the volume of the air in the tube if the temperature rises to 310 Kelvin while the pressure stays the same? Okay, pressure being the same was just to fulfill this statement up here. So that's kind of just don't worry about that. The thing we got to worry about is temperature change now to 310. So actually, this turned out to be a simple question, yeah? Simple, straightforward, direct variation, and asking for you to just basically plug in the number. Number is 310. I didn't need that many digits. Okay. And then it turns out to be volume is approximately 1.26. And I know I said 1 decimal place, but I just feel like that's losing too much information there. So I'm going by the fields this time because it didn't say to specify it. If I really wanted to be perfectly accurate, I could have left K as this number, but I'm not doing that. I'm just approximating. 1.26. What's the what do you call it? Measurement here? It's cubic feet, yeah? Cubic feet. Okay. So yeah, kind of a pretty moderate temperature increase, right? 295 Kelvin to 310. So moderate increase in volume as well. 1.2 cubic feet to 1.26 cubic feet. And here I'm just boxing this ad infinitum. All right, guys. See you in the last portion of our review after this.